Okay, hi guys. I'll be discussing the part 2 of this topic, Unijunction Transistor application and sample problems. So from part 1, we have already solved 3 sample problems. Now let's continue. So let's start with problem number 4. Find the range of R1 to meet the proper UJT turn on and turn off given the following UJT characteristic value. So here we are given with the standoff ratio, the values at the valley point, and the values at the peak point. And here is the equivalent circuit for this problem. So take note that this circuit is actually an application of UJT, which is to generate a waveform, which is the relaxation oscillator. This actually can also be used as a triggering device for an SCR. Now let's solve. So we are concerned for the value of R1. In order to solve for this, we could use KVL from VBB going to R1, and we must determine the value of VR1, and going through the capacitor with the value of VC, or VBB is equal to VR1 plus VC. But take note that we also have here an emitter part of the UJT where we could determine the voltage VE, and VE is parallel with VC. So therefore, VC is always equal to VE. Therefore, we could also generate a Kval equation referring to VBB equal to VR1 plus VE. And this is the equivalent equation for that. And since we are concerned with the value of R1, we must replace VR1 by Ohm's law by using I1 times R1. And the equation will become VBB equals to I1 R1 plus VE. Now, if we want to derive R1, we must move VE at the other side of the equation. That will become I1 R1 is equal to VBB minus VE. And if we will divide I1, we will determine or derive the formula or equation for R1, which is equal to VBB minus VE over I1. Now, we are looking for a range of R1, which means that should not be a single value. It should be a maximum and a minimum value. Therefore, we must check conditions for R1 for it to become either minimum or maximum. So for VE, we could use the condition based on the characteristic of UJT having valley point and peak point. But for I1, we must further check. So again, this is the equation for R1. We have already conditions for VE, and we must also check the conditions for I1s. So we have here the conditions for VE and I1. So for I1, let's check the circuit here. It will pass through the node here. And by principle of Kirchhoff's current law, it should be split to IC and IE. Or in short, I1 is equal to IC plus IE. Now, if we want to determine the conditions for the maximum and minimum value of R1, we must check the condition extreme for this capacitor. And the extremes happen when the capacitor is either fully charged or fully discharged. If we will check the concept, when a capacitor is either fully charged or fully discharged, there will be no current going through or going out of this capacitor, or IC is equal to 0. If this is equal to 0, therefore, I1 will no longer be split to IC and IE, but instead I1 will go directly to IE, or I1 is equal to IE. And the emitter current already have reference values for these conditions, which is at the valley point and the peak point. Or if we will recall the characteristic curve of a UJT, which is shown here, VE ranges from VB to VP. and IE could range from IP to IV. So for the first condition, at the peak point, VE is equal to VP and IE is equal to IP. And at the other point, at the valley point, VE is equal to VV and IE is equal to IV. So we will be using these conditions to get the maximum and minimum values of R1. So let's continue. So for the condition at the peak point, if we will use this equation and substitute to the equation for R1, this will become R1 is equals to VBB minus VP over IP. And to recall the concept, to ensure that the UJT will turn on, R1 must not limit IE at the peak point to less than IP. That is, VR1 at the peak point should be greater than IPR1. Or to summarize, here is the equation. So this given equation of R1 should be modified as R1 should be less than VBB minus VP over IP. Or that equation will help solve the maximum value of R1. Okay, next, for the condition of the valley point, V equals to VV and I1 or IE is equals to IV, substituting those values, R1 will become VBB minus VV all over IV. And recall the concept, to turn off the UJT at the valley point, R1 must be large enough that IE can decrease below the specified value of IV. Or in short, R1 should be greater than this equation, or we will be able to solve for the minimum value of R1. Or in summary, we could use this general equation or formula for getting the value of R1 or the range of R1 from the minimum up to the maximum value. So now we will be able to solve this problem. I already copied here the given. So let's solve for R max. R max is equals to VBB minus VP over IP. Substituting the given VBB, VP, and IP, you will be able to calculate for R max, which is 480.769 kilo ohms. While for R min, VBB minus VV over IV, substituting the values will show here a calculated value of 1.92 kilo ohm. Therefore, R1 must be greater than 1.92 kilo ohm but less than 480.769 kilo ohm, or R1 must be between these two values. And this is the final answer for this problem. Okay.